Hello again on the AI Infinity channel. My name is Bartek and I'm the new lecturer. Today I will tell you about artificial intelligence in video games. We'll start with history, going back to the 70s and 80s, when AI was still very simple, in the form of scripts and not yet true AI. Even games like Pong from 1972, available on arcade machines or Space Invaders, introduced computer opponents. But already in the 80s, AI began to show its true power in strategic games such as chess or checkers, where not every player could win against it. In the 80s and 90s, there were even special chess computers designed just for this purpose. In the game The Hobbit from 1982 on the ZX Spectrum, AI was used to control independent characters who could wander around the entire map, take various actions towards other NPCs, which, combined with the player's actions, sometimes led to situations where the game could not be completed. Years passed, and games became more and more complicated. A new genre of strategic games emerged, RTS, real-time strategy, where players command units in real time. The genre was a big challenge for the computer player. Initially, in games such as Dune 2 or Warcraft, the computer often attacked only with a few units in random places, generally not posing a challenge for the player. To stand a chance of victory, it had to cheat, having, for example, greater resources or numerical advantage. In later games like StarCraft, efforts were made to ensure that bots at higher difficulty levels better managed their army, avoiding giving the computer an artificial advantage outside the campaign. Let's now move on to another aspect of AI in games: NPC reactions to player actions. In games like Ultima 7, independent characters lived their own lives. They went to work, ate meals, and even went to sleep at specific times. Meanwhile, in The Witcher 3 Wild Hunt, AI goes a step further, reacting to the player's earlier choices. Decisions made by the player affect NPC behavior and can change the course of the game. Many games generate content procedurally. This technique, although not directly related to traditional forms of AI, uses advanced algorithms to create a vast amount of varied content. Games like No Man's Sky use this method to generate countless planets with unique ecosystems, making each gameplay different. Minecraft, on the other hand, uses procedural map generation, creating a unique realm. One of the main challenges in game creation is limiting the repetitiveness of NPC dialogues, especially if they are spoken lines. Currently, most games use previously recorded or written lines, which can lead to the repetition of the same phrases, especially in a longer game. This happens, for example, in Skyrim. However, in the future, thanks to advances in machine learning and natural language processing, we can expect NPCs to be able to generate their lines on the fly, reacting more dynamically to player actions and the game environment. One of the forerunners of this type is Cyberpunk 2077, where CD Projekt, in creating the DLC, used a voice generated by AI to recreate the voice of a deceased actor. The growing use of AI in dubbing games or movies concerns actors, some of whom protest. The use of AI voice can bring significant financial savings to producers, and a well-cloned voice is difficult to distinguish from the original. One of the biggest protest actions took place in Italy in February 2023, in which about 2,500 people participated. An approximation of what this might look like is the game Dungeon AI. It is a text game where AI based on ChatGPT generates not only the game world and the climate chosen by the player and other guidelines, but also NPCs, dialogues, random events, and almost all other elements of the game. Each gameplay here is completely different. In Middle-earth: Shadow of Mordor, each AI-controlled opponent has its unique personality, history, and relationships with other characters in the game world. The Nemesis system remembers interactions with the player, including defeats and successes, which affects the development and behavior of these characters. For example, an orc that defeats the player can rise in the hierarchy and become stronger, remembering previous encounters. This makes each gameplay unique, and the game world seems alive and dynamic. AI capabilities are continuously growing. Although the average player usually doesn't need very advanced AI, sometimes AI can be a challenge. An algorithm for a simple game of tic-tac-toe, which ensures a win or draw for the computer if it starts, was already developed in the 60s. A similar script for the game Connect 4 was written in 1988. The program Chinook solved international checkers in 2007. These programs, however, did not use machine learning or any other AI mechanisms. They were rather a set of so-called F instructions, i.e. possible situations, and instructions for what the program should do in a given situation. Similarly, IBM's famous Deep Blue, which defeated world chess champion Garry Kasparov in 1997, contained advanced algorithms, game tree search techniques and heuristics, but is not currently considered full AI in today's understanding. The program could not learn. What is considered true full AI is the program AlphaGo by DeepMind, used for playing Go. AlphaGo can learn. Its training involved playing against itself and analyzing games in a database. Gradually, its level of play increased until it could defeat the greatest masters of this game. The training of AlphaStar, playing StarCraft, and OpenAI 5 looked similar. They were provided with recordings of many different games, and then they played anonymously with people. Initially, these programs could make senseless, random moves, but they quickly learned and in a short time advanced in league play to the highest levels. AI in games has come a long way from simple algorithms to complex systems capable of competing and collaborating with humans at the highest level. These advancements open up new possibilities not only in the world of games, but also in the broader context of technology and artificial intelligence development.